This video is about the bulge in Venus's atmosphere. And this is infrared of Venus, a very turbulent atmosphere, clouds at every level, all the way down to the ground level. The southern part of Venus has two main huge vortices. And notice how half the planet is extremely hot, the other half is extremely cold. That temperature delta is because Venus is close to the sun. It has a lot of greenhouse gases, and it only makes a rotation every 240 something days. This is the bulge, okay? It's not a bulge, it's a wave, okay? And they went as far and had the audacity to call it what? A gravity wave. But wait, just not any gravity wave. It's a gravity wave that didn't even move in the 4 days that these photographs were taken. So what happened? What is it? How can we explain this in simple, logical, understandable terms? Something obvious. First, we got to start and remember, half of Venus is extremely hot, the other half is extremely cold. That the atmosphere of Venus rotates around the planet every 4 days. So that's hundreds of times faster than the planet itself can rotate. And it rotates as you look at it from right to left, depending on what satellite. But the bottom vortex is extremely powerful. There's usually two, sometimes a third one. Now at a certain level in the atmosphere, there's a Y-shaped wave. They call it right there. See, wind-distorted wave, they call it. A wind-distorted wave. Y-shaped feature on Venus's clouds. Well, it's almost always there. Not 100% of the time, but almost always there. And it's a wave. It's an atmosphere wave. It has nothing to do with gravity. It's had to do with wind and wind pressure. Now the thing is that you have to realize Venus, this atmosphere that you're staring at, this very thick and turbulent and windy atmosphere, interacts directly with the solar wind. Venus can turn into a comet, and even some channels have pointed out that Venus looked like it had a tail during some very strong CMEs that hit the planet. And indeed, this picture shows you how the atmosphere of Venus directly interacts with the solar wind. Okay, now we're getting somewhere. So if the wind moves from right to left towards the west, and this is an actual simulation of that Y-shaped cloud moving from right to left towards they call this the west limb, and imagine a very powerful wind coming in the opposite direction. So if there's a direct interaction, it has to somehow impact and influence the shape and the nature of that Y-shaped cloud. And in fact, it could not help but do that. So when you have this planet that is, so extreme on one side and cold on the other, creating a temperature delta, and you have all of a sudden this very powerful wind coming from left to right, and you have the cold wind trying to move from right to left, you can stall that Y-shaped wind. You can stall it and create turbulence in front and in back. And when you create turbulence in this atmosphere and you mix in plasma, you create even brighter infrared signatures. Now look in the upper left-hand corner. Do you see that wave there? Okay, that was taken 2 years ago, people. Okay, so that whatever this bulge is, or trying to, I don't know what the heck, it's a distraction or whatever, but the atmosphere of Venus is prone to waves, lots of waves, and they're all related to the interaction of winds that correspond to specific directions, temperatures, altitudes, and densities. So what happens then when it gets hit by what? A helium cone. Wait a minute. Venus is close to Earth right now, and it's traveling like a month behind Earth, trying to catch up to it, and it will catch up to us. But It's traveling through the exact same helium cone that Earth traveled through. And we've made a dozen videos showing the major compression of our magnetosphere. But wait a minute, Venus doesn't have much of a magnetosphere. We showed you the huge particles that penetrated. So then it has to impact Venus's atmosphere as well. Look at this wave. Okay, you want to call that a gravity wave? That was taken in 2015 by a Japanese satellite. Does that look familiar to you? It should. And that was, guess what? That was taken in December as well. I think it was taken December 15th, 2015. Can you believe that? So, Earth, this is a current position of Earth. Earth, a month ago, was where Venus is today. And what happened a month ago? We had 20 geomagnetic storms in 30 days. Some of them as high as 7 and 8. So, we go back and try to see what the opposite side of the sun looks like. And it looks like the front side of the sun, because remember, Venus is on the other side. This is stereo A. It looks like something's blown the plasma over towards Venus, towards where Earth is, on the other side. You think that's all a coincidence? Maybe, but I can tell you one thing. This isn't a gravity wave. It isn't the largest gravity wave you've ever seen, and it can't be a stationary gravity wave. That is the most absurd thing I have ever seen or heard, and I can't believe any physicist or astronomer would even repeat it. And never mind, half the people that call it a gravity wave can't even tell you what a gravity wave is, because it's theoretical. There you go, another mystery of the solar system solved by the Higher Truth channel.